Today, we will be going over randomized block experiments. Randomized block experiments is one of the many types of experiments that can be used to eliminate biasness, extra variables, and include randomness. Bias is a tendency to lean in a certain answer before the experiment takes place. This can impact the results and skew the statistics of the experiment. If this happens, the experiment cannot be used to conclude a result. This in short means the experiment was a waste of time. Another thing that can ruin an experiment are extra variables that we didn't or can't account for. For example, if we did one test when it's rainy and another when it is sunny, or one test when it's hot out and the other when it was cold. These are environmental factors that we can't control. Another way our experiment can be ruined is sameness within each subgroup. This is bad because we may not have the same mix in each of the separate subgroups. In my example that we will see later on, wood samples are my test subjects. If I pull all of my samples from the same batch, I will not get an accurate representation of all wood samples in that location. To combat these problems, we randomize our samples before assigning them a subgroup within their block, so there will be no favoritism towards one subject, no bias, or difference in environmental or other factors, or batch issues. Let's look at an example where women might behave positively to a medical treatment and men behave negatively. If we do not block, we will see that this will make our data look incoherent, since the treatment will only work 50% of the time and the treatment will be ruled as not good enough. If we separate the women and men into two blocks, then we will see that women respond positively to the treatment and men respond negatively. The treatment will then be ruled as successful for women and find another treatment for men. Blocking will allow us to take into account any obvious variable that we suspect will skew the results. This will ensure our results will be true to the treatment. Within each block, there should also be subgroups for each treatment we want to test. The subjects within each block will be randomly assigned to one of the subgroups. We randomly assign because this will give us the most diversity within the block. Think of it as picking up cards randomly across the whole deck versus picking up cards only in the middle of the deck. We want diversity in each of the subgroups because we want to have an even representation of the whole population. After assigning the subgroups, we then apply each treatment to the according subgroup. Block 1 subgroup 1 will get treatment 1, block 1 subgroup 2 will get treatment 2, and so on. Once all of the treatments have been applied and we record our results, we then compare the 3 treatments within the same block and see which treatment was the most successful. We do not compare block to block because the results may compare how differently the blocks responded to the treatment instead of comparing the treatments against themselves to see which is the best. In my example, I am comparing 3 different treatments on 2 different types of wood. I block according to wood type, then I randomly, with no seeable pattern, separate those blocks into 3 even subgroups each, 6 subgroups total. Then I apply one of the 3 treatments to each group and compare the results between the 3 groups with the 3 different treatments. I do not compare the 2 blocks between each other because I know they have different variables, so I still get skewed data. After comparing the 3 treatments within each wood type, I will decide which treatment is best for each block. Please note that this data was made up and does not represent a real experiment. As you can see from this table I created, redwood responded best to treatment 2, and pinewood responded best to treatment 3.